In this video, I'm going to be going over how we use scientific notation to write really large and really small numbers, and also how we write things that are in scientific notation back into the way that they were originally. So let's say, for example, I have the number 3,190,000,000. So what's interesting about this number is that this is actually the average distance between the Earth and Pluto. And this is so far away that if you were to drive a car at 85 miles an hour straight to Pluto, then it would take you over 4,200 years to get there. So the first thing that we need to do to write this in scientific notation is take note of where the decimal place is. And then what you want to do is you want to move this decimal over to the place value that places it right before the first non-zero number that you have. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9 places, and then rewrite the decimal in that place value. Then what I'm going to do is count how many place values that I moved the decimal over to the left. So the first part of the scientific notation is going to be the non-zero numbers. So in this case, it's going to be 3.19. And the second part of this number is going to be 10 raised to the power of how many place values we move the decimal over. So in this case, since we move the decimal place over 9 places to the left, it's going to be 10 raised to the 9th power. So similarly, this works the same way if you have a really, really small number. So let's say I have the number 0.0000000003048. So, like the last example, I'm going to take note of where the decimal place is and move it in front of the first non-zero value that I see. So in this case, the first non-zero value that I have is this 3 over here. So I'm going to move the decimal place over to the right until it's in front of the 3. And then rewrite the decimal in that place. And then what I'm going to do is count how many place values I had to move the decimal to put it there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first part of this number is going to be the part that has the non-zero values. So the first part of this one is going to be 3.048. And then much like the last example, the second part of the number is going to be 10 raised to the power of how many decimal places we had to move over, how many place values we had to move. But since we moved to the right this time, it's going to be raised to the negative value of that. So since we moved it over to the right 10 place values, it's going to be 10 raised to the negative 10th power. So let's say I had some numbers that I want to move back into scientific notation. So let's say I had the number 4.84 times 10 to the 8th power. So what I'm going to do is I'm going to write this number out exactly how it is in the first part, and then I'm just going to keep writing zeros. Just keep on writing zeros. And we know to write the zeros going to the right because we have a positive power in the 10. And then what we're going to do is move the decimal to the right the number of times that the 10 is raised to. So in this case, we're going to move it over 8 place values. That's going to leave the decimal right here. And then you just rewrite the number. with the decimal in the new place. So this is going to give us 484 with 6 zeros behind it. And then that's our answer. So essentially we're just reversing the process. And let's say we had a really small number. Let's say we had 2.74 times 10 to the negative 7th power. So like the last example that I'm going to do, I'm going to write this number out first, 2.74, and then I'm going to start writing zeros to the left of the 2 because we have this negative power. And then I'm going to move the decimal place however much this 10 is raised to. So I have a 7 here, a negative 7, so I'm going to move the decimal place over to the left 7 places. And then I'm going to rewrite the number with the decimal in the new place. So this number comes out to 0.000000274. So I hope this video was helpful about how we use scientific notation to shorten really long and really small, really large and really small numbers, and then how we can reverse the process to get it back into its original state. So thanks you guys for watching, and I'll see you for the next video.